Have you ever wondered what makes advanced warning signals work? What circuitry is involved to make them function? And how do they know when to turn on? Well, I just happened to be on site today for a new signal installation inspection, and we happen to have this setup, so you're going to get a behind-the-scenes look at how this is achieved. Now, the whole premise of advanced warning beacons or advanced warning signals is to bring awareness to the driver that the signal's about ready to change. And there's many ways to accomplish that. I'm going to show you in here how we are running it. Now, the original design called out for a wireless connection, and we were going to send the output wirelessly upstream to that beacon, and then the receiver would turn on the flasher that way. But into the design process, the designers called out for a conduit to be ran all the way up to the beacon as well. So we opted to just go ahead and run a hardwire connection upstream. So I'll show you both ways how this was accomplished if we would have done the wireless and the wired. So how are we accomplishing this here? You can see up there, phase 6G, or 6G, sorry. That is the green indication. That is for the phase 6 direction, which is coming towards us from the hill. Obviously, it's not green right now. In fact, it is red at the moment. As soon as that phase 4G changes, meaning that the cars are no longer there, it'll go to yellow, then red, and then you'll see that G come back up. So the output, the output of the controller goes to the input of these load switches. The load switches, their whole purpose is to take the output of the controller, convert it to voltage that is usable by the indications. So we have a logic output to the controller, and in return, it changes this to 120 volts, which sends it out the fuel wires, which go out to the indications. What we did there is the phase 6 green input to the load switch. So it'd be the output of the controller, but to the input of the load switch. We grabbed that and fed that over here to this terminal, which is that one right there. From there, we ran that wire and brought it all the way over here to this relay system. I'm going to show you on paper how this plays out. Now, in the original design, like I said, we had this set up for a wireless setup. So I'm going to show you how we had it set up for the wireless, but I'll show you next after that how we did it for the wired. This red wire originally was not meant to be there. This is what we're using for the wired setup. On the wireless setup, we ran the phase 6 green output, which is that logic from phase 6. So when phase 6 green comes on, this logic turns on and comes to here. Over here on this side is 24 volts. Y10, you come down to Y10, there's your 24 volts. So when the green turns on, that logic comes up to here, activates this relay. This closes the leg and sends what's here is the 120 volts. 123, 123 over here is the signal bus, which is 120 volts. So we have 120 volts coming up through here. This leg closes, it continues on over to here. Triggers this relay because you have an AC neutral over here. So when the AC turns on here, this energizes this relay. The logic input goes through there out to the output and will trigger this relay. You just saw that input went off. So that is how, and then from there, actually that's what sent in the radio setup would send that upstream and turn on that flasher when that receiver received that. Right now, I've got a lead on the logic ground and a lead on the output through that relay, and you can hear that it's buzzing right now, meaning that we do not have that phase 6 green. The those vehicles that are approaching us. That green is not up. So at the moment, we are outputting a logic ground to that radio, and now that the green is up, the output has dropped out. Now, let's go back and look at it again and see how we actually have it set up, which is a wired setup going up there, up to the flashing beacon. Instead, we are just taking, what we're doing now is we're just taking this relay out of the picture. We're not using the logic, nothing, we don't need to feed anything to the radio. We're just gonna take that green. When it turns on for phase 6, it's gonna trigger this relay again. That 120, now, as long as this is not triggered, which means if phase 6 is off, it's going to be in this state. So 120 is going to be going to there, which is pin 5. And that red wire is on pin 5. So as long as phase 6 is not on, this is the state that it's in, sending 120 up to that red wire, heading upstream to that beacon way up. You can't see it, Budweiser truck in the way. Upstream, turning on that flasher. And here it is in action. Our phase 6 green is on right now. And I have the lead from this on this wire heading up to the beacon. You can see we're reading, well, 1 volt, nothing major there. So there's no 120 going up to the beacon upstream, meaning it's not flashing. As soon as that phase 6 changes anything other than that green, either a yellow or a red, there we go. Now we have voltage coming out, and that's heading upstream on that wire, and the flashing beacon is working. All right, well, that's it in a nutshell. But the question I have for you is, do advanced warning signals make you slow down because you know the signal's getting ready to change? Or do they make you speed up because you know the signal's getting ready to change? Let me know. See you next week.